Welcome friends. So we are discussing two-port networks. We have solved few problems. Let us continue our discussion. So let us have this figure 14. We have a large network, fairly complex as it seems. So you need to obtain y parameters, right? You need to obtain y parameters of this network. So now the thing is that this network seems fairly complex as it appears, right? Now to analyze this network, it's extremely difficult. If you carefully investigate, you will find a very interesting feature that you see. This is a T network. This is a T network, right? This is a T network. And this is a shaded in yellow. This is a T network. On the other hand, this is a pi network shaded by green. This is a pi network shaded by green. Now these two networks, if you carefully look, they are connected in parallel. They are connected in parallel. So this input current I1, after reaching at this node, let us say this node is X. So it is getting two paths, one along this and another along this. So basically we have a two networks connected in parallel. So you know, if two networks are connected in parallel, then their respective y parameters are added. Okay. So it apparently this figure 14 looks very complex, very large as it appears, but if you analyze it correctly, it is not so very difficult. So simply it is a two network. One network is T network. This is a T network and this is a pi network. These two networks are connected in parallel, right? So let us solve one by one. So let us first calculate y parameters of the T network. Let us first calculate y parameters of the T network. So this is a T network. This is a T network. Now when this T networks is connected to delta and or equivalent pi, all the resistances will become 6 ohm. All the resistances will become 6 ohm. Why? Because it is 2 ohm plus 2 ohm plus 2 into 2 by 2. So it will be 6 ohm. So it is a well-known formula. You should not forget. Okay. So if a resistance is 6 ohm, then that same resistance can be represented by 1 by 6 mho. It is all the same meaning. So this resistance, 6 ohm resistance, is equivalently can be said 1 by 6 mho conductance. So all these resistance can be 1 by 6 mho conductance. So now you know the rule. If a pi network is represented by this, and if they are and their respective parameters or elements are represented in mho, then you can directly write y11 is equal to y1 plus y3, y22 that will be equal to y2 plus y3, and y12 is equal to y21, which is equal to minus y3. So here y1 is equal to 1 by 6 y3 is also 1 by 6, so it will be 1 by 3. y2 plus y3 is also 1 by 3, and y12 and y21 will be minus 1 by 6. So this is our y parameter for T network. Now let us move. Now let us evaluate our, now this is the pi network, 1 ohm each. So 1 ohm resistance can be thought of 1 mho conductance. So it is fairly simple. So if you evaluate the y parameter of this pi network, so it will be y11 will be 2, y22 also will be 2 mho, and y12 is equal to y21, it will be become minus 1 mho. So y parameter of the pi network will be this. Now if you want to calculate the y parameter of the overall network, so what is the rule? Rule is you need to just add. Y parameter of the T network and y parameter of the pi network. It is the T network and it is the pi network. Okay. So you need to add them. So you will get the answer 7 by 3 minus 7 by 6 minus 7 by 6, 7 by 3. So this network is fairly complex. So it is, if you solve its y parameter, its answer will be 7 by 3 minus 7 by 6 minus 7 by 6 and 7 by 3. So this network as it stands, you see it is y11 is equal to y22. So in this respect it is called a symmetrical network. Also you can see y12 becomes y21. Due to that, this network can also be considered as a reciprocal network. So this network shown in figure 14 can depict both. It is symmetrical network as well as a reciprocal network, and in this way you solve the y parameter of this network, right? Maybe it looks very complex, but if you analyze it correctly, appropriately, it's not so very difficult. It's a straightforward problem. Now similar problem, ABCD parameter. Okay, we need to evaluate ABCD parameter, a similar sort of problem as shown in figure 1. It's a long, it's a ladder like network. So it's a long network. Okay, so you need to solve ABCD parameter. So again we shall use a trick. So you see, if you consider this part, only, so it represents a T network. It represents a T network, right? Moving on, if you consider this part, it represents a pi network. So first T network as shown by yellow, and then a pi network as shown by blue, and they are connected in cascade. Why? Because you see, if you see this is a T network, the output of the T network received by input of the pi network. That is why it is connected in cascade connection. So if you evaluate ABCD parameter of the T network, then you evaluate ABCD parameter of the pi network, then you must multiply it together to get the overall ABCD parameter of this network. So let us solve one by one. It is the fundamental equation of the ABCD parameter. So we need to first make V2 is equal to 0 at some point of time, and then we have to make I2 is equal to 0 at some point of time. So open circuiting and short circuiting of the output port we have to make both the way. So as far the figure 15a is concerned, we are doing open circuiting. So V2 is some value, but I2 has no value. I2 is 0. Okay, I2 is 0. So entire this current I1 should be flowing through 2 ohm and this 2 ohm resistance. No current should be flowing through this 2 ohm resistance. So you can write directly V1 is equal to 4I1. Why 4? Because this 2 ohm and this 2 ohm current is flowing. And what is V2? V2 will be this drop. Which is 2 into I1. So from the definition, what is A? A is V1 by V2, which is equal to 2. Okay. And what is C? C will be is equal to I1 by V2. C is equal to I1 by V2. So C will be I1 by V2 will be half. So we have solved A and C of the T network. Okay. Now similarly, if we consider figure 15b, so we write V1 that should be is equal to now I1 is flowing through this 2 ohm resistance, so it should be 2 I1, and then this current is minus I2 because current reverses its direction because we are sorting it, so it will be 2 into minus I2. Again from the current division rule, we write minus I2. What is that? It is the total current, which is I1, into resistance of the other branch. So it will be 2 divided by total resistance, which is 4. So it will be nothing but I1 by 2. Right. So as per the definition, you see D is equal to D, right? D is equal to I1 by I2. Right? D is equal to I1 by I2. So with this, D should be minus 2. Okay. And what will be B? B will be is equal to V1 by I2. What is V1? V1 is equal to 2I1 minus 2I2 by I2. So what will be I1? I1 is equal to minus 2I2. So if you solve this, you will get E is equal to 2 into I1. I1 is equal to minus 2I2. 2 into minus 2I2 by I2. So altogether it will be minus 6. So I2 cancel, so it will be minus 6. So if you solve the transmission parameter of a T network, you will get this value. A is equal to 2, B is equal to minus 6 ohm, C is equal to half mho, and D is equal to minus 2. You will get this value, T parameter, right? Now let us consider pi network, right? Let us consider the pi network. We will follow the same process. Okay. So first we are making open circuiting V1. Open circuiting output. So we have a V2, but I2 is 0. Okay. So what is this current flowing through 1 ohm resistance? It should be V1. This current is V1 because V1 by 1. So this current actually, so let us solve one by one. So V1, okay. So, okay. So this current, as it is understood, it is V1, right? It is V1. So if this current is V1 and this entire current is I1, so this current must be I1 minus V1. I1 minus V1. So we write the KVL equations for you. So input voltage V1, this is V1. So the current flowing through 1 ohm resistance is I1 minus V1. So the drop will be I1 minus V1 into 1. So this term plus this V2 voltage appearing across 1 ohm resistance. So this is. So if you solve this, you will get 3V2 plus V2 minus V1. So with this, we can solve, or we can say 2V1 is equal to 4V2. 2V1 is equal to 4V2. So from therefore we have substituted A is equal to V1 by V2 is equal to 2. That is our first solution. Now with from this equation, one interesting thing, V1 is equal to I1 minus V1 plus V2. So from there on 2V1 becomes I1 plus V2. I1 plus V2. So you need to remove I1 from here. You need to remove I1 from here. Okay. So let me use current division rule. Let me use current division rule. What is that? Okay. I1 minus V1 is it is flowing through this 1 ohm resistance, this current, and this current is same as that of this current, right? Now what is this current? This current is nothing but V2. This current is nothing but V2. So I1 minus V1 is equal to V2. Okay. So it is not required actually. So I1 minus V1 you can directly write V2. So from there you can get V1 is equal to V2 plus V2, that is V1 is equal to 2V2. So with that it is V1 by V2 which is equal to 2, which is our A. And again V2 by 1, so this current V2 by 1, this current is nothing but I1 into 1 by 3, I1 into 1 by 3. Okay, what is the reason of writing this? Okay, let us try to understand. We understand that this current is the current flowing through 1 ohm resistance is V2, or rather V2 by 1, whatever it may be. So this current, using the current division rule, what is this current? V2. This V2 should be is equal to total current, which is I1, into resistance of the other branch, that means this 1 ohm, divided by total resistance. Now total resistance is how much? 1 plus 1 plus 1, it is 3. So that is why it is written V2 by 1 is equal to I1 by 3, I1 into 1 by 3. So I1 by V2 is equal to C, which is equal to 3 mho. Now A solved and A solved and C is solved. Now left is B and C. Let us solve those. Okay. We have Now let us make output short circuited. Let us make output port short circuited. Okay, let me draw the circuit once again. 1 ohm, it is a pi network of each term 1 ohm each. So let me short it again. So this is V1, current should be I1, this is 1 ohm, this is 1 ohm, 1 ohm, and this current must be minus I2. Shorting means current reverses its direction. Okay. So at the first stage, this 1 ohm resistance, this resistance is directly short circuited, so it is effectively out. It is ineffective. It will not create any influence on this network. So what will be this I2? So this current will be minus I2 flowing through this 1 ohm resistor, and which is same as that of minus I2. So this current should be, it is the total current, which is I1 into resistance of the other branch, which is 1 ohm, divided by total resistance 1 plus 1, which is 2. That is why it is written minus I2 is equal to I1 by 2. This is the first relation. So from there you can evaluate D is equal to minus 2. D is equal to minus 2. Thereon, what is V1? V1 should be is equal to minus I2. Why? Because V1 is nothing but this voltage and this voltage. Actually, okay, please try to understand, the voltage or potential of this node is V1 and potential of this node is 0. Why? Because this is 0, this is direct short circuited, so this node also becomes 0. So potential drop existing is V1 and current flowing through is minus I2. So what is minus I2? Minus I2 is equal to V1 by 1. So that is why it is written V1 is equal to minus I2. So from there B should be V1 by I2 is equal to minus 1 ohm. So now we have solved the ABCD parameter of the pi networks as well. So this is the pi network, T parameter of the pi network. So now we can apply, please recall, we have already undergone that very useful tips that if two networks are connected in cascade, then their respective T parameters, T1 and T2 will be multiplied to get the equivalent T parameter. So the equivalent T parameter should be obtained by multiplying T parameter of the T network and T parameter of the pi network. So if you multiply these two matrices, you will get, this is the answer. Okay. So if you have this network, so its equivalent T networks are minus 1410, minus 1410, minus 5 7 by 2, minus 5 7 by 2. So now it is, you can understand that this is the result. Okay, A, B, C, D. So this is the solution. So with this, let me conclude this module here. So from the starting, we have started with different parameters with their definition. Thereafter, we have seen the different interrelationship between any two parameters. We have also understood the concept of reciprocal network and symmetrical network, and finally we have seen a few problems on two-port networks. With this, I am concluding this module here. From the next session, we start a new topic. Now, up to this of the network theory, you will get some essence of the network, that is voltage current equation. And from rest of the course or from the rest of the topics, you will get a total different flavor. That is the transient. We are mainly left with transient analysis and Fourier series. So up to this, up to two-port network, you will get some flavor. That is the voltage current equation, KCL, KVL, stuffs like that. Later on, following to this, starting from the transient analysis, module 7 to module 10, you will get a different flavor. Okay, so let us conclude, let us end this talk here, and from the next session we shall start our next module. Thank you.